This PCB came with a simple fault, but now the fault has become bigger. Now how it became bigger, I will explain to you. So look, these three parts I have changed here. This is one capacitor, which is the fan capacitor. Because its motor was not running, I changed it. There was a little damage here, so that's why I replaced it. And the second thing is this. This is its switching relay. As you can see, its condition has become quite bad, and if you look at this point, it is burned to a large extent. Its second wire was also burned, so that's why I directly replaced this relay with this new relay. Similarly, this capacitor is 33 microfarad 450 volt, so I also changed it because as you can see, it was slightly swollen, so that's why I had to replace it. So as soon as I change these three parts, the PCB is still faulty, there is still a problem in it. Now when we turn this unit on, it is currently working at 16 degrees Celsius temperature, and the important thing to note is that this relay has not switched, it has not turned on. Usually, a tuck sound comes from it, but that sound did not come from this one. Because of this, the E4 error appears on it. You might think that the motor is not even attached to it. So the point is that even when the motor is attached to it, the same error still appears. That's why I showed you, just to demonstrate that the E4 error is appearing on it. Now to check this, we turn this PCB upside down. On this back side, the relay that I showed you from the top has one switching point. These are the relay points that connect with each other when the relay turns on. From this point, I think it connects to this point when it switches. The resistance mark that you can see here indicates the coil of the relay. When this coil is energized, the relay switches or turns on. Now what I do is supply power to the PCB again. After supplying power, we check the voltage across these two coil points. When I checked here, you can see that no voltage is coming here at all. There should have been 12 volts here, but nothing is coming. Instead, it is 0. Now, this switching relay requires 12 volts, and these 12 volts are generated on this capacitor labeled E76. So here we check whether this voltage is being generated or not. Normally, when the PCB is turning on, it means that 12 volts is being generated here, and because of that, the 5 volts is generated further. And after that, the microcontroller starts working. I turn this PCB on just for my own confirmation. I am checking whether 12 volts is actually present here or not. It is 11.90 volts and completely stable with no kind of fluctuation present here. This means that this relay should turn on, and the positive point of this relay comes directly to this point here. So let me show you. See here, we will follow this print. You can see it goes from here. Then here is a jumper. From the jumper, it comes directly here, and after passing underneath, through this diode, it directly reaches this capacitor where we check the voltage. On the positive side, you can see the positive mark, so it reaches here. So this positive point is directly going to the relay. Whereas we also follow its negative or ground point. So look here, when we follow the negative, you can see that it is coming to this pin. This is the print. You can see the trace here. It comes here. And when I followed it, you can see this trace passing from here and coming to this point. So here, what we do is check the continuity first, because if continuity is not present, there could still be a problem if the point is broken somewhere. Sometimes it also happens that these points develop high resistance, which can cause this issue. So here I place one probe on this point and the other on this relay point. In continuity mode, you can see there is a proper beep, and the resistance is also 0. This means the continuity is reaching here properly. The next point we need to follow is to see where this point is going. So when we follow this trace, you can see there is a diode here. Let me show you this from the other side. The diode here is labeled D192, and it is placed here. Similarly, if we follow it further, you can see that the point comes here. At this location, IC4 is installed, which is a ULN2003 Darlington array. The point we are tracing connects here. You can see this is pin number 16, and this point connects to it, which is the output point of the Darlington array. And when the signal comes from the microcontroller, it will come to pin number 1, and then the output will be available to us on pin number 16. Now here, remember that the microcontroller is generating all its outputs as positive signals, and this positive output is what goes to the Darlington array. And the output of the Darlington array is that all outputs are coming out as negative. So now another thing we need to check here is whether both the positive and negative supply are actually present at the Darlington array or not. Let's check that as well. So the Darlington array pin number 8 is on this side, is here, where the ground is coming in, and pin number 9 and this is where the positive is coming in. So let's check both and see if they are actually present. I have powered the PCB on again. Now we will check here, and you can see that both ground and positive voltage are reaching up to here. 11.90 volts is present here as well. So this means that from here, the output should go towards the relay. The relay remains inactive unless triggered by the microcontroller. Without the MCU's command, no switching will occur. I turn the PCB on again, and we will do the testing quickly. So what we do is place the red probe on the positive common point, pin number 9, where the positive voltage is coming, and check pin number 16, where the output from pin number 1 should be coming. But no output is coming here, no voltage at all. Similarly, if we check pin number 1, do we get any voltage there? Here we are getting 7.04 volts, which is too high. A microcontroller does not output such a high voltage. No, sorry, this should be checked from ground. So we place the ground here, and now it's correct. So look here, 5 volts is coming, which means the microcontroller is working and its voltages are present. But from this Darlington array, we are not getting any output on pin number 16. Similarly, when we check here, on pin number 2 there is no voltage, whereas pin number 1 still has 5 volts. This means that this Darlington array is not giving output. I have removed this Darlington array from here, but one thing attached with it. Look, I already showed you this point. There is a diode attached. So this is the negative point, whereas on this side it is attached with the positive point. When you place a diode across a relay coil, you are installing what is known as a flyback diode, also called a freewheeling or snubber diode. While it's a small component, it plays a critical role in protecting the rest of your circuit from inductive kickback. The IN4148 is not a Zener diode. It is a signal diode or high-speed switching diode. Now I will check it without the system. So see, when I connected the polarity in reverse, it is showing completely okay. And when I check it in the correct polarity, it is also showing fine. The diode seems normal, but still, we replace it with a new one. Normally, this diode is used to absorb switching shocks. When the coil gives any kind of spike or backup or short pulse during switching, this diode absorbs those shocks. So now, I will power it again, and you can see the switching sound has come. This relay has switched, which means the system is now completely okay. Now we will also check the motor in this. I will also explain why the E4 error was coming. So what happens is, when the switching relay sends electricity from COM to the on side, then what happens? I will show you. Here are the optocouplers installed. These optocouplers are zero-crossing optocouplers. So if this relay does not switch, then the optocouplers will not generate zero crossing. And when zero crossing is not generated, then the motor installed here will also not turn on. And when the motor does not turn on, then the E4 error is confirmed to appear. So now what has happened is that the relay has turned on, so the supply has reached the optocoupler, and now the system is complete. Now we will check whether the motor is working properly or not. I am powering the PCB again. See, the relay has turned on, and now the motor has also properly started working. Previously, the motor was not turning on at all. But now you can see it has turned on and is working properly. Now here, if our feedback from this motor is correct, then it will show an E5 error. And if, for example, this feedback is not correct, then the E4 error could appear again. But the most important thing is that the motor has started running. Earlier, it was not running at all. This means that if the original motor is installed in it, it will work properly. So there it is. The E5 error has now appeared on the display. This means that the E4 error has been cleared. And now this is a communication error. So this means our PCB is now completely okay.
Click on the left or right thumbnail to watch our next videos. And subscribe. Thank you.